What if humanity built the greatest structure the universe has ever seen? Every second, our sun releases more energy than humanity could use in millions of years.
Almost all of that incredible energy is lost forever into empty space.
What if we could collect almost every ray of sunlight our star produces? This is the first step towards something known as a Dyson Sphere. In 1960, physicist Freeman Dyson proposed a revolutionary concept: a civilization advanced enough to harness the energy output of an entire star. He imagined not one gigantic shell, but billions of independent satellites collecting the sun's energy. Today, humanity uses only a tiny fraction of the energy our sun produces every second. As civilizations grow, so does their hunger for energy. A civilization capable of harvesting the full power of its star is known as a Type II civilization. A Dyson Sphere wouldn't be the size of a planet. It would be as large as Earth's entire orbit around the sun. The sphere would stretch nearly 150 million kilometers away from the sun. You could line up millions of Earths before matching the size of this incredible structure. There isn't enough material on Earth. We'd have to dismantle entire planets. Mercury is the leading candidate, sacrificed to build humanity's greatest machine. Before we could build a Dyson Sphere, we would first have to build factories in space. These factories wouldn't simply build satellites. They would build more factories. The project would soon become larger than every construction effort in human history combined.
Each collector would unfold across several kilometers, converting sunlight into usable power.
Humanity's first Dyson Swarm had begun, and it was only the beginning. Thousands became millions, transforming the inner solar system into humanity's largest. Every satellite constantly adjusted its orbit with incredible precision, avoiding collisions while harvesting maximum sunlight. Captured sunlight could be converted into focused energy and transmitted across the solar system. For the first time, every human settlement in the solar system could share the limitless power of a single star. From deep space, our sun would no longer look like a star, but the glowing heart of a machine built by an advanced civilization. For the first time in history, energy would no longer be humanity's greatest limitation. Limitless, energyless energy would allow computers larger than entire planets. Artificial intelligence could evolve far beyond anything imaginable today. Powered by an entire star, humanity could build starships on an unimaginable scale. With the power of a star behind us, the galaxy itself would become our next frontier. If another civilization built a Dyson Sphere, could we actually detect it from Earth? A partially completed Dyson Swarm would make its star appear slightly dimmer than expected. Even if we couldn't see the structures directly, we might detect the heat they release. Powerful space telescopes may one day identify the thermal fingerprints of advanced civilizations. Perhaps somewhere in the Milky Way, a distant star is already surrounded by the work of an ancient civilization. Every great civilization with a single launch. Before surrounding a star, humanity would first learn to build entire industries in orbit. The greatest mining expedition in history would begin with a journey to Mercury. Entire mountain ranges would disappear as Mercury became the raw material for humanity's greatest machine. From that moment on, the solar system itself would become a giant industrial supply chain. Once machines could build themselves, construction would accelerate beyond anything humans could accomplish alone. Factories would eventually produce billions of collectors, each working as part of a perfectly coordinated network. Year after year, the swarm expanded, until the sun itself began to disappear behind humanity's greatest creation. The Dyson Swarm would behave less like a machine and more like a living technological ecosystem. An ordinary yellow star had become the beating heart of the greatest machine ever built. Humanity had crossed a historic threshold, becoming a true Type II civilization. Millions of people could live inside enormous rotating habitats, built entirely in space. Travel across the solar system would become as routine as crossing continents today. With nearly unlimited energy, even moving an entire planet could become an engineering project. The Dyson Sphere would not be humanity's final achievement. It would be the beginning of our journey to the stars. Every collector depended on perfect orbital precision. A tiny mistake could echo across the entire swarm. Even the smallest malfunction would trigger an immediate automated response. The greatest threat wouldn't come from space. It would come from the star itself. Billions of machines reacted within milliseconds, protecting the swarm before the storm could strike. Even under the fury of our sun, the Dyson Swarm endured, repairing itself almost as quickly as it was damaged. All it would take is one missed correction. In space, collisions don't burn. They shatter. A single collision could create thousands more, unless the swarm reacted immediately. Only a fully autonomous intelligence could respond quickly enough to stop a cascading disaster. The greatest machine ever built would survive not because it never failed, but because it could heal itself. From hundreds of light years away, our sun would appear as nothing more than another ordinary star. But careful observations would reveal something that nature rarely creates. The excess heat surrounding the star would become the strongest clue that someone or something was harvesting its energy. Another civilization might not see us directly, but they could recognize the unmistakable fingerprints of our engineering. The moment we surrounded our star, we announced our existence to the galaxy. To build the greatest machine in history, we may have to erase an entire world forever. Nearly every home, colony, and spacecraft would depend on the uninterrupted flow of energy from a single system. A machine this large would never truly be finished. It would require constant care for generations. Every civilization must decide what it is willing to sacrifice for its future. If humanity could build a Dyson Sphere, would it be our greatest achievement or our greatest gamble? From a single flame to the power of an entire star, humanity's story has always been one of impossible dreams. The sun had not changed, but everything around it had. For future generations, a star surrounded by human engineering might seem as ordinary as the moon appears to us today. And if we could build one around our star, perhaps we are not the first. Perhaps the greatest question isn't whether humanity can build a Dyson Sphere, but what incredible dream we'll dare to pursue after that. The Dyson Swarm had become more than a power source. It had become the nervous system of an entire civilization. Energy flowed across billions of kilometers, as effortlessly as information flows across the internet today. For billions of people, limitless clean energy would simply become part of everyday life. Questions that once seemed impossible to answer could finally be explored with virtually unlimited energy. Humanity had learned to capture the power of a star, and with it, reshape its destiny. With the energy of a star, even frozen worlds could begin to awaken. Changing an entire atmosphere would take generations, but with enough energy, it could become possible. A planet that had been lifeless for billions of years could one day become green again. Entire worlds could be redesigned, not by nature, but by engineering. One star could nourish not just one planet, but an entire family of living worlds. Our sun is already traveling through the Milky Way at incredible speed, but what if we could choose its destination? By redirecting a tiny fraction of the sun's energy, a civilization might produce an almost imperceptible but constant thrust. Over millions of years, even the smallest push could change the destiny of an entire solar system. One day, moving our own star could help future generations avoid hazards that unfold over cosmic timescales. A civilization that can harness a star may one day do something even more extraordinary. Guide that star across the galaxy. With nearly unlimited energy, humanity could finally prepare for its first true journey to another star. Instead of carrying enormous amounts of fuel, the spacecraft would ride on a beam of light. Driven by light itself, the spacecraft began its journey into interstellar space. Beyond the edge of our solar system, the silence of interstellar space stretched for trillions of kilometers. After generations of dreaming, humanity looked upon the light of another sun. Not through a telescope, but with its own eyes. Humanity had finally crossed the immense gulf between the stars. Every spectrum, every molecule, could reveal whether life had emerged on another world. For the first time, human technology touched the surface of another potentially habitable world. Even traveling at the speed of light, the first message home would take years to arrive.
The journey to one star was never the destination. It was the first step toward an entire galaxy.
Before cities could rise, humanity would first build a single safe place to survive. Far from Earth, a new generation would grow up knowing another world as home. Every harvest brought the colony one step closer to complete independence. A civilization can nigh on supply ships forever. It must learn to build everything for itself. Humanity no longer belonged to just one world. For the first time, we had two homes among the stars. For the first time in history, a human was born beneath the light of another sun. To this child, Earth would not be home. It would be history. A new world would create new traditions, while never forgetting where humanity began. Separated by light years, yet united by knowledge, science, and a shared future. Once we learned to harness the power of a star, the galaxy itself became our horizon. One civilization now lived beneath many different stars, separated by distances that could never truly disappear. Each new world quietly shaped the people who called it home. Over thousands of years, different environments could gently influence how future generations adapted. But they would still share a common origin. The speed of light would still define the rhythm of every conversation between the stars. Different skies, different worlds, different futures, yet all part of the same extraordinary human story. Once humanity mastered the energy of a star, we began searching for others who may have done the same.
One distant star appeared perfectly ordinary, until astronomers looked beyond visible light.
Extraordinary observations require extraordinary evidence. Every natural explanation had to be tested first. We might never see another civilization directly, only the subtle fingerprints of its engineering. Perhaps the greatest discovery will not be finding another civilization, but realizing that someone, somewhere, once asked the same question about us. The Milky Way contains hundreds of billions of stars. So where is everybody? We have already discovered thousands of planets, and there may be billions more. For decades, humanity has listened carefully, and the universe has remained remarkably quiet.
Perhaps somewhere along the path from life to a stellar civilization, there is an obstacle few worlds ever overcome. Or perhaps the universe is still young enough that our story is only beginning. It would begin not with a spaceship, but with a pattern hidden inside astronomical data.
Extraordinary claims demand years of careful testing before they can be trusted.
If the evidence survived every test, the announcement could become one of the most important moments in human history.
Perhaps for the first time, every person on Earth would look toward the same star and ask the same question. Whether we are the first or simply the latest, the search itself may become humanity's greatest adventure. Eventually, one star would no longer be enough. Across millions of years, the same engineering could be repeated around star after star. Humanity had not conquered the galaxy, but had learned to live within it. In theory, this is what astronomers call a Type 3 civilization, one capable of using the energy of an entire galaxy. And if one civilization could one day master an entire galaxy, what possibilities might exist beyond galaxies themselves? Even a civilization spanning one galaxy would still be surrounded by billions of others. The universe itself is organized into an enormous cosmic web stretching across unimaginable distances. Some researchers have imagined civilizations extending far beyond a single galaxy, but this remains entirely speculative. Even the most advanced civilization would still face the fundamental limits imposed by the expanding universe. Whether humanity ever reaches this future or not, every great journey begins with a single question. What if? A Dyson Swarm would become the largest machine ever built, with billions of independent parts working as one. Remaining in orbit would require billions of tiny adjustments every single day. No single computer could control a structure this vast. Intelligence itself would need to become distributed. The sun would not always be calm. Every major solar storm would become a system-wide engineering challenge.
To survive for centuries, the swarm would need to repair itself, long before humans even noticed a problem.
Managing billions of independent orbits would become the greatest air traffic control system ever created. Most collisions would be prevented long before the spacecraft ever came close to one another. Natural hazards could never be eliminated, but they could be anticipated. In space, even a fragment smaller than a coin could become a serious engineering problem. True stability would not come from stopping change, but from constantly adapting to it. Nothing lasts forever. Not even the stars that give us life. As the sun grew into a red giant, survival would depend on moving with it. The next home would not be chosen by chance, but by centuries of careful observation. We would not move the star. We would build a new future around another one. Civilizations may rise and stars may fade, but curiosity always finds a new sunrise. A Dyson Swarm would not simply be a machine. It would be the combined effort of countless generations. Every great achievement began with a question that once seemed impossible. The greatest discovery may not be the one we make, but the one the next generation dares to pursue. No matter how far we travel, every journey begins with one small world. So, what if we built a Dyson Sphere? Perhaps the answer is not about the machine itself, but about what humanity could become while building it. Collecting the sun's energy was only the beginning. The real challenge was delivering it where it was needed. Instead of moving fuel across space, energy itself could travel at the speed of light.
Receiving clean energy in space would become just as important as generating it.
For billions of people, the greatest megastructure ever built would simply mean reliable, clean energy every day. One star could power an entire civilization if we learned how to use it wisely. With abundant energy, even entire asteroids could become valuable building materials. Instead of launching factories from Earth, future industries could be built entirely in orbit. Nearly unlimited clean electricity could transform sunlight into the fuel for tomorrow's exploration. Nearly unlimited clean electricity could transform sunlight into the fuel for tomorrow's exploration. With energy no longer scarce, the outer solar system could become our next scientific frontier. A Dyson Swarm would not solve every problem, but it could change what humanity is capable of achieving. No single nation, or even one planet, could safely control a system this enormous. Protecting the swarm would require defending not only hardware, but every command traveling through the network. Managing limitless ambition would still require careful decisions about limited resources. The safest systems are not those that never fail, but those designed to recover gracefully. In the end, the greatest challenge would not be building the swarm, but learning to trust one another enough to share it. For most people, life inside the Dyson Swarm would feel surprisingly ordinary.
Children would grow up learning orbital mechanics, the way previous generations learned geography.
Daily travel might one day include journeys between worlds instead of cities. Abundant energy would allow scientists to ask questions that are impossible to explore today. The greatest technologies often disappear into the background, becoming part of everyday life. A true Dyson Swarm would not be one object, but billions of independent spacecraft working together. Most of the raw materials would likely come not from Earth, but from the countless asteroids already orbiting the Sun. No single generation would finish this project. It would become a mission lasting centuries. Every engineering achievement in history would be only a tiny step towards something this vast. The greatest cost would not be measured in money, but in generations working together toward a single vision. The journey toward a Dyson Swarm may have already begun, one launch at a time. Long before people built around the sun, robots would learn how to build in space. The resources for humanity's largest project may already be waiting in space. A Dyson Swarm would not appear overnight. It would grow, one satellite at a time.
The greatest obstacle may not be technology, but deciding to begin.
If another civilization built a Dyson Swarm, could we detect it from Earth? A civilization using enormous amounts of energy would also release enormous amounts of waste heat. Extraordinary discoveries demand extraordinary evidence.
And careful verification.
This dip at 20% is still unresolved.
Nature can imitate technology, which is why astronomers test every possibility before drawing conclusions.
Perhaps the question is not whether Dyson Swarms exist, but whether we've looked closely enough to find them.
Our galaxy contains hundreds of billions of stars. So where is everybody?
This contradiction became known as the Fermi paradox. There may be many answers, and we still don't know which, if any, is correct. Perhaps intelligent civilizations are still rare, and humanity is simply among the earliest. The universe has not answered us yet, but we have only just begun to ask. Every civilization-changing project begins with a single launch. Before building around the sun, we would first learn to build permanently in space. The first collector would be small, but every future swarm must begin somewhere. Every failure would become another lesson, making the next generation of spacecraft stronger. History rarely changes in a single moment. It changes one successful step at a time. To build around the sun, humanity would first need factories that could operate beyond Earth. In the future, the first workers of space may not be humans, but machines. Space factories would transform raw atoms into the building blocks of a solar-powered civilization. The road to a Dyson Swarm would begin far from the sun, with a fleet of robotic builders. The journey from one small spacecraft to a star-enclosing civilization would begin with a single piece of technology. The first collectors would look tiny compared to the sun, but they would represent the beginning of something enormous. One collector became hundreds. Hundreds became a network. To harvest a star, humanity would first need to understand it. For the first time, humanity would capture a tiny fraction of the power of a star. A Dyson Swarm would not be built in one moment. It would grow slowly, one machine at a time. When millions of machines surround a star, coordination becomes the greatest engineering challenge. Each collector would be independent, yet together, they would function as one enormous machine. At this scale, humans could not control every detail. The system would need to manage itself. Even a civilization that controls a star must still respect the power of nature. Humanity would no longer simply live near a star. It would live with the power of one. With enough energy, humanity's civilization would no longer be limited to a single planet. With abundant energy, Mars would become not a replacement for Earth, but a second world for humanity. New homes would not only be built on planets, but also among the stars themselves. Energy abundance would not break the laws of physics, but it could allow us to push them to their limits. The greatest achievement of a Dyson Swarm may not be controlling a star, but creating a civilization capable of reaching beyond it. Even a civilization that controls a star must still obey one of the universe's oldest rules. Energy eventually becomes. Building near a star requires materials capable of surviving one of the harshest environments imaginable.
A Dyson Swarm could provide enormous energy, but it could not erase the distances between worlds.
Energy may become abundant, but the universe still has a speed limit. A Dyson Swarm would make humanity incredibly powerful, but the universe would remain vast and mysterious. Once a civilization controls the energy of a star, the next question becomes, what lies beyond it? Without faster-than-light travel, reaching other stars may become a journey measured in generations. With enough energy, even tiny spacecraft could be pushed toward the stars. The first travelers between stars may not be humans, but the machines that prepare the way. A Dyson Swarm could be the beginning of a journey that lasts longer than any single human lifetime. The question is not only whether humanity can build a Dyson Swarm, but whether it should.
Greater power brings greater responsibility. The challenge would be using it wisely.
The greatest achievement of a Dyson Swarm may not be the energy it provides, but the possibilities it creates. Every civilization is defined by the questions it dares to answer. Perhaps the greatest question is not whether we can build a Dyson Swarm, but what kind of civilization we become along the way. The sun has powered life on Earth for billions of years. One day, it could power an entire civilization. Humanity's greatest achievements have always begun with curiosity. The future of humanity will belong to those who continue asking bigger questions.
Perhaps our greatest achievement will not be controlling a star, but learning from the universe around us.
The journey to the stars begins with a single idea and the courage to imagine what comes next. With the energy of a star, a civilization could transform not only matter, but information itself. Abundant energy could allow artificial intelligence to solve problems far beyond today's limits. With enough energy and computation, civilizations might explore the universe not only physically, but virtually. Even with the power of a star, the greatest mystery may still be intelligence itself. A Dyson Swarm would not simply give a civilization more power, it would redefine what is possible. If advanced civilizations exist, their greatest engineering projects might leave traces across the stars. One possible clue would be excess infrared energy, the signature of heat released into space. The galaxy contains hundreds of billions of stars. each with its own story waiting to be discovered. The universe has been listening silently for billions of years. We are only now learning how to listen back. Perhaps the greatest discovery in the universe will be discovering what we are capable of becoming. Building a Dyson Swarm would mark the moment humanity became more than a planet-bound species. Great civilizations are not built in a day. They are shaped by thousands of generations. A civilization's greatest creation may not be its machines, but the knowledge it leaves behind. Perhaps our greatest legacy will be the questions we send into the future.
In the vast universe, a single star may become the beginning of an unimaginable journey.
A Dyson Swarm may not be science fiction, but reaching it would require centuries of innovation. The path to a Dyson Swarm would not be one invention, but thousands of discoveries connected together. Compared with anything humanity has built before, a Dyson Swarm would redefine the meaning of engineering. Every journey toward the stars begins with the same thing: a question.
Whether humanity builds a Dyson Swarm or not, the dream reveals something important: our desire.
Every journey toward the stars begins from one small world we call home. The sun has shaped our past. Perhaps one day it will shape our future among the stars. Perhaps the greatest structures of the future will not stand on worlds, but orbit among them. The universe is filled with possibilities. The only question is how far we are willing to go. Maybe one day, humanity will touch the power of a star. But the journey begins with a single idea.
Launching every piece from Earth would require enormous amounts of energy. A Dyson Swarm would need a different strategy.
Close to the sun, Mercury contains enormous amounts of material that could one day help build a solar civilization. A star-scale project would require factories that build other factories. At this scale, automation would become essential. Machines would need to build the machines that build the swarm. The path to a Dyson Swarm would not be a single construction project. It would be an industrial revolution across the solar system. A project surrounding a star would require resources beyond anything humanity has ever organized. Before building around a star, humanity would need to learn how to build in space. A Dyson Swarm would not belong to one generation. It would be a project passed through centuries. The true value of a Dyson Swarm would not be the structure itself, but the energy it unlocks. The greatest projects in history are not measured by years, but by generations willing to continue them.
Abundant energy would not solve every problem, but it could remove one of civilization's greatest limitations.
With the power of a star, humanity could ask questions that are impossible to answer today. With enough energy, humanity could create new homes far beyond the surface of Earth.
A civilization with the energy of a star could also gain new ways to protect its future.
The greatest achievement of a Dyson Swarm may not be controlling a star, but discovering what humanity can become. Once a civilization controls the energy of one star, the next challenge is reaching another. A galaxy-wide civilization would not appear overnight. It would grow one star system at a time. The Kardashev scale imagines civilizations by the amount of energy they can use. A Dyson Swarm would... Even a civilization powered by stars must still live inside the rules written by the universe. A Dyson Swarm may not be the end of humanity's journey. It may only be the beginning. Unlimited energy could transform civilization, but energy alone would not create a perfect world. A Dyson Swarm could provide enormous power, but the future would still depend on how humanity uses it. With enough energy, humanity could transform from a planetary civilization into a spacefaring civilization.
The greater the power of a civilization,
the greater its responsibility to use that power wisely. Perhaps the greatest achievement of a Dyson Swarm would not be the energy it captures, but from a small planet around a single star, humanity began imagining something impossible. The sun would no longer simply be a star we orbit. It would become the foundation of an entire civilization. Perhaps the greatest purpose of reaching the stars is not control, but understanding. Even after reaching the stars, the universe would still hold countless mysteries waiting to be discovered. Maybe building a Dyson Swarm is not only about capturing the energy of a star, maybe it is about discovering what humanity can become.
Some of humanity's greatest achievements began as ideas that seemed impossible.
The original vision was not a giant shell around a star, but a vast collection of structures capturing its energy. The difference between science fiction and science may come down to one word: orbit.
Our star produces more energy every second than humanity has used throughout its entire history.
Every civilization that reaches the stars must begin with a first step. A Dyson Swarm would not float around the sun. Every piece would need to dance perfectly with gravity and motion. Even sunlight itself pushes against every structure placed near the sun. Controlling a Dyson Swarm would require coordinating more machines than any civilization has ever built. Capturing energy is only half the challenge. A civilization must also learn how to dispose of the heat. A Dyson Swarm would not just be a machine. It would be an entire artificial ecosystem built around a star. The first builders of a Dyson Swarm may not be humans. They may be the machines we create to work beyond it. Space contains the raw materials needed for expansion. The challenge is learning how to use them. To build something around a star, the first step may be creating factories that can grow. Machines may build the structures, but human imagination would create the vision. Machines may build the structures, but human imagination would create the vision. The first few collectors would capture only a tiny fraction of the sun's power, but they would mark the beginning of a new era. The first century would not create a star-sized structure. It would create the foundation for one. Like every industrial revolution, growth would accelerate as the ability to build more builders increased. A project this large would become part of civilization itself, passed from one generation to the next. After centuries of effort, a civilization could finally begin harvesting a meaningful fraction of its star's energy. The universe operates on timescales far beyond a human lifetime. Some dreams require If another civilization built a Dyson Swarm, its greatest clue might not be light, but heat. A Dyson Swarm would change the way a star appears, creating a possible fingerprint across the galaxy. On the Kardashev scale, controlling the energy of an entire star would represent a civilization far beyond our current level. The universe contains billions of stars, yet we still have no confirmed evidence of another star. Perhaps somewhere among the stars, another civilization is asking the same question. Before reaching the stars, humanity must first learn how to live beyond its own world. A civilization powered by a star could create new homes where none existed before. With greater energy and knowledge, humanity may begin exploring not only the universe, but itself. The purpose of reaching the stars may never be the destination itself, but the endless search for knowledge. Building a Dyson Swarm would not mark the end it would mark the beginning of a much larger one. For thousands of years, humans have looked at the stars and wondered what might be possible. Every step of civilization has been a journey, from using the energy around us to reaching for something greater. On this small world, a species learned to look beyond its limits. The universe is vast, but curiosity has always been humanity's greatest engine. The question is not only whether we can build a Dyson Swarm, but what kind of civilization we choose to become. The star that gave us life could one day become the foundation of our future. Even among the stars, we will always remember the small blue world where it all began. The future is not something we discover. It is something we create together. Maybe the greatest journey is not reaching the stars, but becoming the kind of civilization that can reach them. Every civilization begins with a question. The future depends on the answers we create. The builders of tomorrow may be inspired by ideas imagined today. Perhaps our greatest creation will not be the structures we build, but the knowledge we leave behind. The universe is not empty of mysteries. It is full of questions waiting for someone to ask them. The future of humanity is still unwritten. The next great chapter begins with imagination.